you a little idea of what we're going to be looking at, volume is different than surface area or area, where we were looking at how many squares. This is three-dimensional, so you're actually seeing how many cubes will fit into the shape. So for example, this one has a rectangular prism. Okay, so you can see the cubes actually filling it up. And it asks you how many unit cubes did it take to form the bottom layer. What's our answer? How many? None. 3 by 3. So if I fill in 9 here, it'll let me keep going. All right, how many layers do you think we would need to fill up the entire cube? Cookies? 3. So how many total cubes would it take to fill? 27. So what did we do? We found the area of one layer, and then you're going to multiply by the number of layers. So we know that the area of the base is big B, right? Whatever the base might be. That's a hexagon, 1/2 ANS. It's a square, S squared. And then you're going to multiply by the number of layers. Brett, did you have a comment or question?
No, I was going to say it's, I thought you were asking something else. And then I realized, never mind.
Now for cylinders, while I'm here on this little explanation, okay, if you were to try to put cubes inside of a cylinder, there'd be like extra space. Like think about ice cubes in a glass. So whenever you do a cylinder, instead of putting in cubes, you're going to think about how many circles would stack up on top of each other. So the area of one circle is pi r squared, right? So that'd be one circle, and then you're saying like how many circles you would stack on top of each other, which would be the height of the cylinder. So the formula for that one's going to be pi r squared times h instead of big B times h. So that's just a little explanation of the formulas we're about to go over. But of course, you'll have your formula sheet. It's also important to notice when we do volume, we will have to use cubic units instead of square units. So volume is the space that a figure occupies, and it is measured in cubic units. How many cubes fit inside? So for example, inches cubed, centimeters cubed, which can also be read cubic inches or cubic centimeters. Now remember, we had two types of prisms. We had a right prism and we had an oblique prism. The volume will remain the same whether it's right or oblique. If it's tilted, it still has the same number of layers. It just happens to be on a slant. So the volume of a prism, any prism, could be a pentagonal prism, an octagonal prism, a triangular prism, is going to be big B times h. Remembering that big B is the area of the base. We've practiced a lot. And then capital H stands for the height of the prism. Now, I also put on the volume of a rectangular prism, which you don't have to necessarily know this formula. You could use this one and just find out what big B is. But a lot of you are familiar with seeing this formula, length times width times height, for a rectangular prism. So that will be a little faster method if you see that it's a rectangle, and you don't have to do B times H, but it's the same. L times W is what big B is. Remember, the length would be here, width, and height. And then we also have our cylinder, which the cylinder formula technically is the same as the prism, big B times H. However, in a cylinder, the base is always a circle. So we know the area of a circle is pi r squared. So if you're going to memorize one, I'd probably, or put one on your sheet, I should say, probably be that one. And then down here, just a little review of what all of our variables stand for. So remember, B is the area of the base. So if the base is a triangle, we would use 1/2 little b times little h. If it were a rectangle, we would use length times width. If it were, I just have a pentagon, but any polygon, we would use what formula? 1/2 ANS, or 1/2 AP. And then who remembers our trapezoid formula? We saw that on Friday. So we could have the base being a trapezoid. Maddie? Good. Okay, remember, capital H is the height of the prism, but you can also think of it as the segment connecting the two bases. And R is, of course, the radius. So you no longer have to find P, the perimeter of the base. That doesn't show up in any of the formulas. You just have to find big B, which is the area of the base. And then tomorrow we'll look at the pyramids and the cones, which you'll learn are just a fraction of what the prism would be. Find the volume of each figure below. First of all, what shape is this first one? A rectangular prism. If you notice a rectangular prism, the easiest formula to use is length times width times height, but that only works for a rectangular. So if you'd prefer, just always do big B times H, that's fine also. But this makes it kind of easy. You just plug in your numbers. Oops. Not that it matters where you put them because multiplication is commutative. We should get 4,800. Again, cubic centimeters. And you can only use LWH time for a rectangular prism. All right, the next one is what shape? A triangular prism. So we'll use big B times big H. Now over here, what they've done is they've taken one of these surfaces and they've drawn it separately for us so that we can see what's going on. So you can see that it is an equilateral triangle, 8, 8, and 8. So we would know that it was 60, 60, and 60, which means the 8 would be bisected in half to be 4 and 4. Yes. So big B again is the area of the base, which will be 1/2 base height. So you can see the base is 8. What would the height be? What would the height be using your special right triangles? What? 4√3. Across from the 30 is S, across from the 60 is S√3. So this will be the base, the whole base is 8, and the height is 4√3. So half of 8 is 4, 4 times 4 is 16. So big B is 16√3 square inches. What is the height of the prism itself? Not the height of the triangle, but the height of the prism itself. 10. Distance from base to base. So we'll have 16√3 times 10, which would be 160√3. Might as well just leave it in simplest radical form. We don't have to reach for our calculator. And again, that will be cubic inches. Next to our cylinders. Cylinders are easier because you don't actually, when you're finding big B, it's the area of a circle. So you could either use your BH formula, or we know that since the base is always a circle, the area of that is pi r squared times h. And just plug in. Radius is 3 times 8. 3 squared is 9. 9 times 8 is 72. So we'll have 72 pi. Centimeters cubed. And units are going to be really important on your next quiz. Make sure you can differentiate between surface area and volume, because you'll have both on the test. Now this is an oblique prism. Again, the volume does not change. It's just the circles are slanted like a little bit as they're being stacked. But it doesn't change the formula, it doesn't change any of the numbers you plug in. And you do tell us the diameter is 8, which would make our radius 4. You'll just notice that the height, instead of being like a side of the cylinder, it'll be a dashed line, but this is still your height, distance from circle to circle. And then 16 times 16 will get us 256 pi cubic meters. Now the last two are going to get a little bit more challenging. They're going to give us the volume and ask us to work backwards and find the radius or the height. So just using algebra, they tell us the volume of a cylinder is 392 pi square feet. It should say cubic feet. That's a typo. The height of the cylinder is 8. Find the radius. So let's start with our formula. V equals pi r squared h. Substitute in what we know and make sure that since this has a pi, that you do write the pi in your formula. So this will be 392 pi. Now just because it says cubic inches does not mean you cube this number. That's just the units. You do not cube 392, you get something really, really big. Okay, radius we don't know. Height we do know, so we're going to plug that in for h. And now what would we have to do to solve this using our algebra skills? Marquise? Good, I see multiplication. The inverse is to divide. You're going to divide by 8 and pi at the same time. You could do it 2 separate steps, but it's a lot easier. The pi's will just cancel each other out over here. And so we'll divide 392 by 8, and we'll get 49. And then the last step would be square root. Undo a square with a square root. And we'll get that the radius is 7. Now the radius is just plain units, so this would be just regular feet. Okay, another one with the same typo. The volume of a cylinder should be 320 cubic feet. The diameter of the cylinder is 8. Find the height this time. Again, also start with our formula. Plugging in our volume. Now be careful you don't plug in 8 for the radius. 8 is the diameter, so the radius is actually 4. We're finding the height. So you would want to go ahead and evaluate that 4 squared is 16. And then we would again undo multiplication with division. So we'll divide by 16 pi on both sides. We should get our height is 20. Remember, you can always take that and plug it back in and make sure when you multiply you do get 3 things. You can check your answers on those. Alright, I know the closure sometimes we skip over because it's just like a little ending question, but this one is something I want us to go over. I want you guys to try it on your own, then we'll go over it. It is the volume of a composite figure. Now again, volume of a composite figure is a lot easier. Do you have this on your paper or no?
Yeah.
Oh. Can you imagine it's not there? Can you scribble it out? Normally they won't break it up for you and you'll have to figure out those numbers on your own. So let's make sure you know how to. So again, volume is a little bit easier because you're just finding volume and adding them. What 2 shapes do we see? Obviously you can kind of see them through the scribbles, but what 2 shapes do we see? a rectangular prism and a half of a cylinder. Okay, so we're going to find the volume of the rectangular prism, and we're going to add the volume of half of a cylinder. So to find half the cylinder, you just multiply 1/2 or divide by 2 at the end of your cylinder. Now, what makes the problem hard is when I take this away for you to come up with the measurements for what everything is. So we can see that it'll be 12 by 4, but what you don't know is you don't know at the time how tall it is. Okay, you don't know that that's necessarily 12. We can find this out though using the fact that if this is 12, this is 12. The diameter of the cylinder is 12, which will break this into 6 and 6. So then we know a radius can be drawn anywhere. So the radius could be drawn from here to here, and it would still have to be 6. So at that point we can do 17 minus 6 to get that this part has to be 11. So that's why I said scribble this out, because it just kind of gives it to you on a quiz or a test. I'm not going to give you those split up figures. You're going to have to problem solve to find those. All right, which means for our rectangular prism, we'll just do length times width times height, because that's a lot easier than having to do BH. It's kind of the same thing, I guess. But. So that will be 12 times 4 times 11. And then for our cylinder, we're going to do 1/2 pi r squared h. And we can see the radius is 6. What is the height of the cylinder? This is another place you will plug in a wrong number and then get in. It is 4. Remember that the height of a cylinder would be the distance or segment connecting the two circles. So since this is tilted on its side, the height of the cylinder is 4. And they do ask us to round to the nearest cubic inch, which means we will be plugging in our pi key, or 3.14. So who could round this to the nearest cubic inch, which means the nearest whole number? Using your calculator. Katie? Okay. And this would be cubic inches.